Okay, let's have a look at the first of our fractional expressions. Well, you might say there's nothing to do here at all, it's just 3 over 4. But it's here to illustrate the fact that a fraction is really a sum that someone hasn't bothered to write the answer down. What this fraction means, 3 over 4, is 3 divided by 4. If you pop that into a calculator, you'd get the answer 0.75. But let's do it longhand. 4 into 3. I have to put a couple of zeros here because I know it won't go in nicely. 4 into 3 won't go, so we write 0 on the top there and pop the decimal point on. And we carry the 3 across to make 30. 4 into 30. Well, 4 times 7 is 28, and that's the maximum it can go, so it goes in 7 times remainder 2. 4 into now 20 goes 5. And there's the confirmation of 0.75. So 3 over 4 is equal to 0.75. And that's the technique for producing any decimal from a fraction. Just do the sum that up to now no one's bothered to do. Okay, let's have a look at the second fractional problem. And this is designed to illustrate the technique of top and bottom decks and keeping them separate. Well, you might say, hang on, that 5's neither on the top nor the bottom deck. Well, in fact, it's on the top deck. Let me show you. 5 can be written as 5 divided by 1. We've got a fraction. So if I use that version of 5, the top and bottom decks become very clear. We've got 5 over 1 multiplied by 3 over 4. So here's the top deck, and here's the bottom deck. And we treat those sums completely separately. This is 5 multiplied by 3 divided by 1 multiplied by 4. And this equals 5 times 3 is 15 divided by 1 times 4, 4. And that's your answer. So hopefully you can see that top deck and that bottom deck are totally independent. Two completely separate sums to reach the fractional answer. Okay, our third fractional problem asks us to add 5 to 3 over 4. And yes, of course, the answer can be described as a mixed number as 5 and 3/4 as a mixed number. But let's do it and keep it in fractions. So we know already that that 5 can be transformed into a top and bottom deck fraction by just writing it as 5 over 1. And we've been asked to add 3/4 to that. Now that we can't directly do until we get both terms on a common denominator. So to get 5 over 1 up to something over 4, I have to multiply both top deck and bottom decks by 4. Effectively, I'm multiplying by 1, but it's a special 1. 4 over 4 is 1, but it's expressed as 4 over 4. Now using our top and bottom deck separate rules, we've got that to be equal to 20 over 4. So coming back over here, our sum equals 20 over 4, that's instead of the 5 over 1, plus 3 over 4. Well, we've got 20/4 effectively here and another 3. This is 23, and it's divided by 4 because we've got 23 of those quarters now. And that's the answer. Okay, let's have a look at the last problem. This is a subtraction of fractions. 5 over 6 minus 3 over 4. Now this is slightly more difficult than the previous example because it's not obvious what common denominator we should sit these on. We're looking for a number that both 6 and 4 go into, leaving an integer answer. So what number is on the times table of 6, which is also on the times table of 4? Well, it happens to be 12. 6 times 2 is 12, and 4 times 3 is 12. So let's choose 12 as our common denominator. So the routine is this. 6 into 12 goes twice. Twice times 5 is 10. There's our minus sign. And carrying on the routine, 4 goes into 12 3 times, and 3 times 3 is equal to 9. Now we've got the top and bottom decks effectively working separately. Common denominator on the bottom one and a simple sum on the top. 10 minus 9 is 1. And the answer is 1 over 12. So I hope that's shown you the value of considering a fraction in terms of what's on the top deck and what's on the bottom deck. And very often those sums, top deck and bottom deck, are totally separate.